Today we have the oral exam for the computer graphics course. For those who are not part of the class, you're going to see teams are going to be presenting their work on their final project. So without further ado, the stage is yours.
Okay guys, so we did the dancing robot. My name is William Delong.
I'm McTiernan.
And we have a little presentation. We'll go through the slides fairly quickly here just to give you an idea of our project. But, sorry? So yeah, overview, dancing robot. So we have the robot itself, the room. So we tried to make it a little more immersive and give it kind of a nightclub feel, I guess. We have physics working on the robot, and then we're going to give you like a little demo. So I joked kind of, I guess, in the proposal about doing Gundam style as like a dance routine, but we actually ended up following that fairly closely, and we tried to implement as many moves as we could from the actual like video, I guess.
Okay,
yeah,
so for the robot design, the main color of the robot, we try to make it look kind of like steel. We basically just go between two different colors of gray, and then the parts, we implemented a few different shapes. We have the cubes like we always started with, and then much like the disc golf, we made like an octagonal prism where we calculated all the vertices and the normals of each side, plug that all in to make like a draw like cylinder function. And we also did the same thing like that, except if you took how the top and bottom of the octagons were like flat, we just took that center point of all those triangles and kept that, and then the outer points moved them down, and that created like a ball type object.
Which we use for, we use that for as like a disco ball in the dance club. So yeah, this is our room design. So I mean, hopefully everyone kind of knows what a dance club would look like if you ever experienced that. But
Or disco.
yeah, so even if you watch like a movie, but this is what we went for. So we try to achieve the floor and then the lighting and have some sort of disco ball and of course music. So yeah, we'll keep going here. More on the programming side of things, we tried to, the easiest way we decided to move the different parts of the robot was to first get a decent like data structure so that we could draw and handle each of the parts of the robot individually. So we use,
So basically, what we use is the hierarchy. So if we wanted to move the whole arm, we can move the whole arm. But if we also want to just move at the elbow, we can move at the elbow while the whole arm's moving. Same thing with knees. So basically, this allows us to create joints at the proper locations. Otherwise, basically, you'd spin around standard axes, which
it was tough. I guess it was kind of a curve, like a learning curve at first. But once we got that data structure, it allowed us to do like easy rotations with almost any point of the robot. So yeah, this is kind of talking about the physics. So there's sort of designated joints within the robot, and then we apply accelerations either as rotations or translations, so we can move the robot or just rotate joints. And it's kind of weird to think about, but in terms of like your body, you never actually do any translating, like any rotation, like your arm rotating, you're not moving, you're just rotating around your shoulder. And then if you're going to bend it, it's just rotating here. So really we just did a lot of rotations, and then any translations is the whole robot moving, like jumping and things like that. Do you want to help with this?
So in terms of the actual dancing, what we did is we mapped different dance moves and different sequences of the dance moves to different keyboard buttons. So basically, like we'll do one that would like move its hands to its hips and then like assume like a squatting position, and then like start like jumping around and like space bars jump. Basically, there's a ton.
Yeah,
really. So there's about 4 rows of the keyboard that are just filled with stuff.
And yeah, we can jump into an actual demo.
No, I got choreographed for
Do you want me to run them out?
And also one thing we didn't really talk about too, we had the HUD. So you want to talk about that?
Yeah, sure. So here's our dance club.
Here, you can wait below.
Can you zoom out a bit? So yeah, this is the disco ball. So we have like the light rotating, so it gives kind of a strobe effect on the robot himself. And this HUD over here isn't exactly necessary, I guess, but it just gives you some sort of idea of what's actually going on in the robot. So if you do, now this isn't a dance move. These were used for testing purposes, but this will show you kind of the rotations that are happening. So you can see it's divided up into a tree structure, and you can see all the different rotations, the velocity, the angles, etc. I hope that will stop. You may have to reload. So anyways, yeah, that was kind of the HUD. So as the robot's dancing, you can see the different forces and accelerations and stuff that's working on the entire robot. And up in the right corner here, this used to be a video player, and I thought it would be a good idea to connect it to YouTube, because YouTube is a huge database of audio and video. But we're not connected to the internet, so that is just blank right now. So if it is connected though, you can play the song, but I have my laptop here, so if anyone you're ready to do the dance thing.
And try to dance, I guess.
Yeah. So I'll play the music just to give you guys more of an immersive experience.
You can also show it to us later from your laptop if it has a internet connection.
Yeah.
Oh, yeah, this you should be able to.
You'll get the feel of it.
Yeah, you'll get the feel of it. And the colors are a little bit clearer on the actual screen too. It's not as pale, but anyways. He's very flexible. Basically, our demo of the dancing robot. Any questions?
How do you make the light go like that?
The cube itself, we have the light rotating the same rotation as the disco ball itself, so it's actually switching the location of the light. And
Just leave this on.
oh, sorry.
It's easier for you to.
And there's really just a little bit of trial and error, but eventually, like, we got something we really liked, and it gives it. You can really see like the.
So you're rotating the coordinates of the light?
Like when you set up light, the location of it.
Yep.
So I'm just changing it as the cube is rotating. We're setting it to the rotation angle.
It gets rotated the same as the cube does.
Okay, got it. So it's
but
basically
it's-
specular effect that we're seeing,
Yeah.
right?
Yeah, all the ambient specular and diffuse are all being used on the robot, and it gives it that strobe kind of effect, and you can really see the 3-dimension. You know, you can see the cylinders and the obviously boxes, and the eyes glow a little bit too, even. But yeah.
You're using cylinders?
Yeah,
Yes.
those are the arms are cylinders. You can see his stomach is a cylinder.
The shins and quads are cylinders.
Yeah, those are all cylinders, and then
It's an octagonal prism, like the disc with ball team?
Yeah, it's octagonal prism basically. So
Yeah.
it's-
And then the disco ball itself, like AMAC described, it's basically a cylinder just with a, instead of, I guess it's gone now, but Eve described the triangles of the top of it, and then it's just the extended center point.
How did you make the face of the robot?
What we did actually is just removed the front, one of the walls of the cube, and then inset a black cube so it kind of looked like it was floating. And then did the same thing, remove the front face, and then just put in, it's actually
Three.
Yeah, 3 spheres actually.
Three
The eyes
disco
are
balls.
spheres, and then the
Yeah.
mouth is a really stretched out disco ball.
Okay.
Yeah. Yeah.
Cool. Any questions, guys? How did you split the work?
Yeah.
I handled most of all like the dancing stuff and the drawing of the robot, while Bill did.
I did more of the behind, like, I handled like the data structure and all the physics and how we handled the input for different movements on the robot itself.
But we worked on most of it together.
Yeah, anytime we worked on it, we were mostly working off the machine, so.
It's got a little crazy into machines. And
Yeah.
one other thing that we didn't really mention is with the gravity, all the arms and all the movements are set by accelerations. So that's why if you like start clapping, it would go clap faster and faster and faster.
Yeah. Yeah, that was the easiest way to get it to look natural, was actually use Newton's law of physics. So,
Any other questions?
The floor, how do you make that?
what's that, sorry?
The floor is got a texture or?
Yeah.
It's, yeah, it's similar to the way that we handled it in the lab where we did the textures on the different cube, and it's just its own texture. The no walls around it are on the top, and just the bottom, the floor is its own texture.
It's a 3D texture again, right?
Yep. Yeah.
Good. Any more questions? Good. Thank you very much.